wait for 2 more minutes for the others to join in, and then we will start the lecture. In a while, just wait for one or 2 minutes. Okay, Bismillahirrahmanirrahim. Let's start with the lecture. I welcome you all to the virtual session of IT 101 of the week number 2. Sorry, IT 446 of week number 2. And yes, regarding the chapters, Muhammad asked that there are 4 chapters in the virtual on the blackboard in this first week week. So as I told you, if you remember in the classroom, that the content which is present in the blackboard, our previous experience is that it is a little bit lengthy for the students. So we will give you some summarized slides to go through. Okay, so we will deliberate. We will define the mechanism soon, inshallah. Don't worry about the length of the content. Okay. So let me share the slides with you guys so that we can start the lecture. Please raise your hands if you can see the slides. Okay, thank you very much. Thank you very much. Thank you very much. Okay, so okay. Now, if you remember that we discussed the first part of this week's lecture in the classroom, and there was a second part, and it's not a very lengthy part, but it has some very basic information for you guys, which we have to cover in the virtual class. So let's start with this. Okay, also before I start, let me tell you about some of the administrative things that we will be needing to understand before we move on in this course. The first and the foremost important thing in the virtual class is the attendance of the virtual class. And there might be some, some students who think that the virtual attendance is not important, but it is equally very important. And excuse me. You are expected to have at least the minimum requirement in the virtual class, and you can only have a maximum of 4 absents in the virtual class. Anyone who will have 5 absents or more, he might be disqualified from the course. Okay, so keep in mind that the virtual class has attendance, and I again repeat that be attentive, and be present in the virtual class. Already the university is giving a lot of favor to the students by having virtual classes, because you can take these classes from anywhere. They are easy. It's not very difficult to attend this class. Okay, I don't know why many students they miss virtual classes. You can log on from anywhere. You can log on from your computer, from your tablet, from your device, from your mobile, while driving, while at work, while doing something. So it's not that difficult. So already you have been facilitated that you are having one class as a virtual class. So just be present in the virtual class. Okay, the second thing is that you may also discuss when we will be having assignments. After the assignment has been submitted on the blackboard, then you may also discuss about the assignment. If you have anything that you want to discuss regarding the assignment, okay, you can discuss in the virtual class as well. The third thing is that it is expected that most of the students they will go through the slides that we cover in the classes, and it is expected that you know previous week's lecture material and you understand the things and you have come prepared in the class, so that if we discuss something or if I ask you any questions, you are prepared to answer and you know the things. Okay, the more you discuss the things, the more better is your understanding of the course will be. Yes, Jabbar, please write in English. Okay, the only medium of writing in the blackboard text area is in English. Yes, Jabir, what do you want to say? Can you please write it again? We will be finishing both of the chapters from the two books. Okay, so let's start. Okay, so this chapter is about data, and we'll continue with what we were studying in the class. So data is a collection of objects and their attributes. Okay, so what is data? It is some attribute, some object with an attribute. Okay, so we can have different objects and different attributes which are associated with those objects. And we know that an attribute is any property or the characteristic of an object. For example, if we talk about eye, it is an object. It can have an attribute like color, and this attribute color can have some value. It could be red, it could be black, it could be green, it could be blue. Okay, so data is the eye, attribute is the color, and the name of the color is the value of that attribute. Excuse me. So attribute is also known as the variable, field, characteristic, or feature of the data. So a collection of attributes describe an object. An object, for example, a person. If we say a person is an object, he may have a number of attributes, whether he is married, his marital status, his taxable income, okay, and other things. So these all are features or the variables or the properties of that attribute. Now attribute values, they are any numbers or symbols which are assigned to that attribute. And there may be distinction between attributes and their values. So some attributes can be mapped to different attribute values. Same attributes can be mapped to different attribute values. For example, height can be measured in feet or meters. Okay, it can have different values. When we talk about feet, it will have a different value. When we talk in meters, it will have a different value. Also, we see that different attributes can be map to the same set of values. For example, attribute values for ID and age, they can be integers. Okay, so ID and age, these are two different attributes, but they are mapped to the same value, which is integer. Both will be storing values in the form of integers. But the properties of attributes, they can be different. Okay, ID has no limit, for example, but on the age on the other side has a maximum and the minimum value limit. So measurement of length means the way you measure an attribute is somewhat may not match the attribute properties. How then what we can do, we can have some types of attributes. For example, there are 4 different types of attributes. We name them as nominal attributes, ordinal attributes, interval attributes, and ratio attributes. Now nominal attributes, they are simple attributes. They have simple values. For example, ID numbers, we can write any number as an ID number. Eye color, it can be a simple ID number. Okay, meaning that there is no order in that, there is no interval in that, there is no ratio in that. It is just a value. Example could be ID numbers, eye color, or zip code. They can be any values. The second type of attribute is the ordinal attribute. Now this type of attribute has some order present between the values. For example, if we grade something on a scale of 1 to 10, 1 being the worst, 10 being the best, and someone writes a value of 5, it means that that thing is on the average. As for an example, if some company representative asks you to provide a feedback about the Lay's potato chips on the scale from 1 to 10, where 1 means that it has the worst taste, 10 means that it has a very excellent taste. So if you grade it and you grade 9, it means that it is on the higher side of the scale or the order. Okay, so this is an ordinal type of attribute. So it can be, example could be grade. If someone is getting A, it means that he's performed well in the exam. If someone gets D, it means that he did not perform very well in the exam. Similarly, height could be in the order, for example, tall, medium, short. We know that a medium height is greater than the shorter height and it is less than the taller height. Okay, we already know. So anyone whose height is a medium, we know that he is taller than most of the persons and he is also shorter than most of the persons. Okay, then the third type of attribute is known as the interval attribute. This type of attribute has some starting point and the ending point, and the value lies in between these starting and ending points. As for an example, the calendar dates, they start from 0 and they end at most 31 or 30 or 28 or 29. Similarly, temperatures can have some intervals, and Celsius or Fahrenheit temperatures can have some intervals. Can anyone give me any other example of an interval attribute? Yes, wake up the class, let me wake you up. Okay, any example of interval attribute from your side? Hroob Muhammad is typing something. Any example? Yeah, marks. Marks could be, yes, marks could be in the interval scale. Counting is another type of attribute. We can also call term marks in that attribute, but marks could be negative as well. Any other example of interval attribute? Age is also another type of attribute. Okay, let me first discuss the ratio attribute, then I will ask you again my question. Okay, now the fourth type of attribute is known as the ratio attribute. This is the type of attribute which has a starting point of 0. Okay, for example, temperature in Kelvin scale. We know that the temperature starts from 0 Kelvin, which means that minus 273 degrees centigrade. But the same is not true for Celsius temperature. Excuse me. Celsius temperature does not start from 0. Okay, so length also starts from 0. Okay, a thing could have a 0 length or no or greater than 0 length. We do not say that the length of two objects is -1. It cannot be the length. Also, the time starts from 0. Counting starts from 0. We cannot count as a number as -10. Okay. Now this was the ratio scale. Now what is an interval? Can you give me any other example of the interval scale? Interval scale has some fixed intervals starting in add or subtract. No, interval scale. The values in the interval scale. Shifts like the shifts of the duty of a person. Yeah, that could be a good example of an interval scale. A person can have some working shifts, and he can have a minimum of 2 shifts and a maximum of 10 shifts, for example. So 2 and 10 is the interval. In between that interval, he can have any number of shifts. Yes, Mohammed, that's very good, excellent. Okay, any other example from someone? Then we will move on. Yes, weekdays. Yes, weekdays can be an example. Or we can say a week. We can have a starting day, which is Sunday, let's say, and the ending day. Yeah, salary could be in the interval scale. Okay, good. So let's move on. Now, the properties of the attributes depends on which type of the following properties any attribute possesses. Attribute can have a distinctness attribute property when it is equal or not equal to any other attribute. It can have an order property where it is greater than or less than any other attribute. It can also have addition when it can be added to another attribute, and it can have multiplication or division attribute property, which can be multiplied or divided by another attribute. Okay, so nominal attributes, they have distinctness property. Okay, ordinal attributes, they have distinctness and the order property. Both properties are present. Whereas the interval attribute have distinctness, order, and addition property. Whereas the ratio attribute has all 4 of the above properties. Okay, so now we see there are some attribute types and their descriptions, and there are some examples and operations on those attributes. Let's quickly go through them. Okay, so nominal, these have the values which are just different names. For example, nominal attribute provide only enough information to distinguish one object from another, which could be not equal to or not equal to another. For example, zip codes, employee ID numbers, eye color, gender, which could be male or female. And there are some statistical operations that we can do on the nominal attribute. For example, mod, we can take mod, entropy, contingency, correlation, chi-square test. These are different statistical operations that we can do on the nominal attribute. The second type of attributes are the ordinal attributes, and the values of an ordinal attribute provide enough information to order the objects. For example, we may have an order of less than or greater than. In a week, Sunday comes before Monday or after Monday. Sunday comes before Monday. So there is an order, okay? If we are comparing between two heights, one is short, one is medium, which will come first? Which is lesser? That is, the shorter height is the lesser one. So in these types of attributes, we can have different orders. We can know from the attribute value that where in the set attribute set the order is of that particular value. Okay, then hardness of minerals, for example, could be explained in terms of good hardness, better and best hardness. And you can also have grade, for example, A, B, C, D in your examination. They can define the order. Okay, a person who has not performed well, he might have taken D. A person who has performed well, he might have taken A. Okay, so if someone is taking A, we already know that he is at the top of the order. And there are some operations on the ordinal scale, which includes median, percentiles, rank correlation, run test, sign test. Okay, then the third type of attributes are the interval attributes. So the differences between the values are meaningful. For example, unit of measurement exists. Examples could be calendar dates, temperature in Celsius or Fahrenheit, and there are some operations which we can do on these, which are mean, standard deviation, Pearson's correlation, T and F test. The last one is the ratio. For ratio variables, both differences and ratios are meaningful. And example of such type of attributes are temperature in the Kelvin, monetary quantities like salary, counts, age, mass, length, electrical current. And there are some operations which can have, for example, we can have geometric mean, harmonic mean, percent variation, and so on. So for nominal, any permutation of values could be there. These are the transformations. And for ordinal and order preserving change of values might be there. For interval, we can add in the interval in the variable, and for the ratio we can also multiply and divide for the variable. Now, besides these categorical variable definitions of the attributes, we can also have two other types of properties of attributes, or different types of attributes. The first one could be discrete attribute, and the second one could be continuous attribute. Now, discrete attributes, they have only a finite or countably infinite set of values. For example, zip codes, counts, or other set of words in a collection of documents. So they are often represented as integer variables. They could be represented in binary attributes, and these are a special case of discrete attributes. The continuous attributes, on the other hand, they are real numbers, and the values are in real numbers. Examples could be temperature, height, or weight of a person. So practically, real values can only be measured and represented using a finite number of digits. But most of the time in real world, I will just give you an example. We measure them practically in finite number of digits. We can measure some values after the decimal point, and we cannot go to infinite number of places after the decimal point. So continuous attributes are typically represented as floating point variables. Okay, so now discrete value, for example, if you are counting the apples, you will count them as 2 apples, 3 apples, 4 apples, 5 apples, okay? So these are discrete. Apples could be 3, 1, 2, 3, and 4. Apples cannot be 1.1, 1.2. No, they cannot be. But on the other side, now this is discrete. On the other side, if you talk about continuous attributes, a person's height could be 170 centimeter. A person's height could again be 170.1 centimeters. A person's height, if the apparatus permits us to measure, could also be 170.1 centimeters. Okay, so we can go to any number of decimal places, but in practically we fix some decimal places because the other minute details are not that worth of measuring. Similar is the case with weight. A person's weight could be, let's say, 80 kilograms or 80.1 kilograms, 80.2 kilograms, 80.21 kilograms, 80.25 kilograms, and so on. So there is continuity. You can go to any different any decimal places as you want. So these type of attributes are known as continuous attributes. Whereas on the other side, in discrete attributes, you cannot have continuity in them. You cannot subdivide them into different things, different parts. For example, a zip code is a zip code. If the zip code is real of any city is like, for let's say 44,000, it cannot be 44,001. It is 44,000. Similarly, as I have given you the example of counting, counting is in a discrete fashion, not continuous fashion. Now, types of data sets could be in the form of record, graph, and they can be ordered. So record is a data matrix, as you recall the topics that you have covered in the database course. So it is a data matrix, and we can have a record in the form of document data and transaction data. Whereas graph, a very good example of the graph data structure could be the World Wide Web, and also molecular structure of different molecules. And then we have some ordered data in the form of spatial data, temporal data, sequential data, genetic sequence and data we'll discuss. In this type of data, the order of things matters. Okay, now there is important characteristics of structured data, and that different characteristics of structured data, and these are dimensionality, sparsity, and resolution. Throughout this course, you will deal with dimensionality. For a brief note, please remember that dimensionality means the number of attributes associated with any data. Dimensions are equal to, or dimensions are the same number, that is the same name given to attributes or features. Dimensions, attributes, features, they are the same things. Okay? The column things that you see in the databases, these are dimensions or attributes or features of the data. Now, the curse of dimensionality, it's a problem in data mining, and it means that if you increase the number of dimensions or the number of attributes of an object, it is easy to classify them. Okay, but on the other hand, the problem becomes more complex and may take a lot of time or may increase the computational time. So dimensionality also brings curse to the problem, and sparsity and resolution we'll discuss in the subsequent lectures. Sparsity means only the presence counts, and resolution means the patterns depend on the scale. Okay, we can change the scale of the things in order to make the data more visible. So record data that consists of a collection of records, each of which consists of a fixed set of attributes. Now you can see that from the database course, we said that record is a tuple or the horizontal row in a database. So associated with that record are some attributes or features or the dimensions of the data. So you can see from the table. So data matrix, if data objects have the same fixed set of numeric attributes, then the data objects can be thought of as points in a multidimensional space, where each dimension represents a distinct attribute. Now you can represent that the data matrix in the form of a multidimensional space, and such data can be represented by an M by N matrix, where the M are the rows, one for each object, and N are the columns, and they are also one for each attribute. Now you can see that we can represent the data in an M by N matrix, as you can see in these slides. So document data, each document becomes a term vector, and each term is a component attribute of the vector. and the value of each component is the number of times the corresponding term occurs in the document. Now you can see how many times they are occurring in the document, and they have placed the frequency in the attribute column. Then there are another type of data which can also be termed as transaction data, and these are special type of record data where each record measures a transaction and it involves a set of items. And for example, this example we also did in the class. And example, consider a grocery store. The set of products which are purchased by a customer during one shopping trip constitute of a transaction which has a transaction ID, TID, as you can see in the table, and the individual products that were purchased are known as the items. Items are bread, Coke and milk, then beer and bread, then beer, Coke, diaper and milk, and so on. Okay, so we discussed that such type of rules discovered are known as, which type of rule discovery is this? Do you remember from the face-to-face class we discussed these? Which type of rules are these? Yes, who will answer? When a person goes to a grocery store or somewhere and he buys one thing and he is most likely to buy another thing as well, he buys a set of things. Ordered. You are a little bit near. When if a person buys bread, he will also buy Coke or milk. We named it as there is some rule discovery. Yes, we predict that they come together, but it has a special name. This type of okay. Anyone else? Yes, Jabir. Association rule. Yes, Jabir, you're right. Okay, so it is known as association rule discovery. Yes, good. So, and when you also know the order in which he will buy those things. Yes, Jabir, what do we call that? Sequential rule discovery. Yes, very good. Okay, good. So we also know that the sequence is there. Okay, good. So you see that these are the transaction type of data. Then we may also have graphical data. An example could be internet could be a very good example. The networks where different devices and computers are connected at different nodes in the network, and traffic is flowing from one node to another. Another type of example of graph data is the HTML web pages. If you click on some link in a page, it will take you to another page which is represented by the circles. Then if you click back button there, it will take you back. If you click another link in that page, it will take you to another page, and so on. So that could be another very good example of the graph data. Excuse me. Another example of the graph data could be in the form of chemical data or the molecular structure of the molecules. You can see that the figure on the slide is a representation of the benzene molecule. It is represented as C6H6. The black dots in the middle are connected with each other, and these are the carbon atoms, and they are connected with the hydrogen atoms, the white circles, and together they form a benzene molecule. Okay, just wait a minute, let me drink water. Okay, so here we have sequences of transactions. We can have transactions grouped together and they form a sequence. For example, items A and B, they are these events are the elements of the sequence, and they can they can be occurring before D and CE, and so on. You can see other sequences. Now these sequences are also sometimes very important. For example, in the form of genomic sequence data. You know that genes are there in the human cells, and genes are made up of different proteins, and these proteins are made up of different amino acids, and we can represent an amino acid by any English letter. For example, A, B, C, D, E. Different amino acids are represented by different letters. Now the data that you can see in the screen, it's a representation of the genomic data, and the repetition of the sequences, they define different proteins, and hence you can predict or know the protein structure of the genes. So they are in some order. Okay, then we have another order data which is known as spatiotemporal data. Over here you can see the average monthly temperature of land and ocean. The area in the blue is the coldest area, and the area which is very bright, very dark red, that is the hottest area. And you can see that some of the hottest area are in Australia, the outback, and also in Africa and Middle East, and on the north and the south the regions are colder. Now when we talk about data quality is also very important. So what kinds of data quality problems are there, and how can we detect problems with the data, and what can we do about these problems? Now there are three questions. The first one is, what kind of data quality problems can arise? The second thing is, how can we detect problems with that data? And the third thing is that what can we do about these problems? So examples of data quality problems, or what kind of data quality problems could be there, are noise and outliers, missing value, duplicate values. Data can have some noise, data can have some missing data values, and data can have some redundant or duplicate data values as well. So what is noise? Noise is anything that refers to a modification of the original value due to some distortion in the channel, due to some malfunctioning of the operators or anything. So distortion of a person's voice when talking on a poor telephone is one example, and the snow effect on the television, the white and black effect on a television screen, and it used to be there in the previous television devices when the signals were analog, and we used to have some antennas placed on our rooftops. And what is an outlier? Outlier are data objects with the characteristics that are considerably different than most of the data objects in the data set. And sometimes the outlier is very important, and we cannot miss it. Sometimes the outlier is not at all important to us. Okay, for example, these data in the red circle, they are outliers of these clusters of data. Now how what are the reasons for the missing values? The reasons for the missing values in the data could be that the information is not collected. Like for example, the people decline to give their age and weight in a survey, or the attributes may not be applicable to all cases. For example, if you are getting the annual income of the people, then children are not applicable. The annual income is not applicable to the children. And how you handle these missing values? Now, one method of handling this missing value is to eliminate those data objects which are having missing values. The second method is that we can estimate some missing values. The third method is that we ignore the missing value during our analysis of the data. And the third method is that we replace all the possible missing values with their weighted probability values, so that we fill in the gap of the missing value. Now then the fourth problem is the duplicate data or the redundant data. So data sets may include data objects that are duplicates or almost duplicates of one another, and the major issue is comes when emerging data from heterogeneous sources, from different sources. An example could be the same person with multiple email addresses. Okay, you have an account in Samsung in your mobile phone, and you are also backing up your data, and if you combine them together, you will have different redundant data as well. So data cleaning is a process of dealing with duplicate data issues. You need to clean the data. Okay, so in the subsequent lectures, we'll be dealing with data pre-processing, and there are methods, there are different techniques, there are different issues with data pre-processing. We will discuss the aggregation of data, sampling of data. We also want to reduce the attributes or dimensions of the data, and then we need to find some feature sets which are discriminative of the data, and we can have feature creation, discretization and minorization, and attribute transformation. So these are all the topics which we will be covering in the subsequent lectures for data processing. Okay, with this this week's lecture is over, and our course is covered for this week. So any questions from the things that we have covered today? Okay, okay. The slides, I will give them to you. By the next week, inshallah, you will be getting the slides from us. Okay, so if you do not have any questions, let's call it a day. Inshallah, I will see you next week in the same class and in the face-to-face class. Okay, till then, stay safe, stay healthy, and remember me in your prayers. Okay, good night. See you, inshallah. Fi amanallah. Thank you, everyone. Jazakallah khair.